Alright, so today I'm going to teach you guys how to figure out the empirical and molecular formulas of compounds, or how chemists can figure that out. So what does the empirical formula of a compound show us? Here's what it does. The empirical formula gives us the lowest whole number ratio of the atoms of the element in a compound. So let me give you an example of this. An empirical formula would be something like this. If we have acetylene gas, which is C2H2, that is the molecular formula, the empirical formula is going to be the simplest whole number ratio, which would just be CH. So acetylene's gas actual molecular formula is C2H2. The empirical formula is the lowest whole number ratio of the atoms of the elements in the compound. So C2H2, that is the actual, this is the actual molecular structure. Come on. The CH, this is going to be the empirical formula. I can give you guys a couple more examples of this. So let's say we have sugar, which is C6H12O6. That is the molecular formula of sugar. And if we wanted to know the empirical formula, it would be the simplest whole number ratio. In this case, the least common multiple would be a 6. So it would simplify down to CH2O. So sugar, that's the molecular formula. Its empirical form would be CH2O. So this is going to be the molecular formula. This would be the empirical formula. Okay. I want to make a special note here that sometimes the molecular formula is the actual empirical formula. For instance, if we were to look at water, which is H2O, well, water's molecular formula is H2O. So this is going to be the molecular formula. Now, if you were to simplify water down, well, it is in the smallest whole number ratio. So water's molecular and its empirical formula are going to be the same. And today, I'm going to show you guys how chemists can figure out the molecular formula, or the empirical formula first, then they can do some other experiments, and they can get the actual molecular structure. That's where we're going today. I'm going to show you how chemists can actually know. Well, how do we know that H2O is H2O? And how do we know that sugar is C6H12O6? Well, there's a process. First, chemists figure out the empirical formula. That's why we're learning about this, and I'll show you how they do that experimentally. Then they do another experiment to figure out the molecular formula. So that's the big picture of where we're going today. Here's some more examples of molecular and empirical formulas. So we have ethene gas. That's going to be used in a welder's torch. Then we have styrene, which is used in packing peanuts. Ethene is C2H2. The styrene is C8H8. If you simplify those down, they end up having the same empirical formula, CH. But obviously they have different molecular formulas, and obviously they are used as two different compounds. Okay. So let's look at how we can first find the empirical formula of a compound. How do chemists even know what the empirical formula is going to be? Well, here's what they do. They can get the percent data of the compounds in each sample by using a fancy apparatus like this one right here. We don't have this at Crosby Ironton, but they would burn it. They would kind of use it to absorb other things, and eventually what they can do is they can figure out the percent data. And that's all we need. We just need the percent data to figure out the empirical formula of a compound. And here's how we do it. It says, a compound is analyzed and found to contain 25.9% nitrogen and 74.1% oxygen. What is the empirical formula of the compound? So here's what we do. The first step that we do with any empirical formula is you have to do this. We're going to make an assumption. We are going to assume we have a 100 gram sample. And the reason why we're going to make this assumption is therefore we can take these percent signs and we can turn them into grams pretty easily. Because if we have 100 grams and 100%, they're going to be the same thing. So for instance, that 25.9% nitrogen, we can now change this to a gram if we make that assumption that we're going to be looking at 100. If we have a 100 gram sample of it, we're going to have 25.9 grams of nitrogen and we're going to have 74.1 grams of oxygen. Okay, so that's step one. You're going to make that assumption. Step two, we can't compare grams to grams. As you guys know, some atoms are bigger than others, so we just can't compare grams to grams. It'd be like comparing apples to oranges. So what we're going to need to do, step two, is we're going to convert each one of those gram samples to a mole. So down here, that's what I'm going to do next. Is I'm going to take the 25.9 grams of nitrogen and I'm going to convert that to a mole. Let's see if I can find a working calculator here. I'm going to go like this. And then actually, I'm going to hit pause. I got to find a calculator.